Exponents, they're on another level. Does anybody remember what exponents are? Yeah?
Numbers that you multiply by?
Kind of. So an exponent is that little tiny number that's in the upper right-hand corner, written somewhat like another level. And all it's doing is telling you how many times you should multiply that number. Traditionally, I like to skip a lot of vocabulary, but it's probably kind of important for this packet because the words are telling you what to actually do with the problem. Should I call on people? Oh, no? That's bad? Is this a bad start? Oh, you guys' brains aren't kicked in yet. Oh, dear. Too bad. Brody, what's standard notation? Oh, geez. Anybody? Oh, dear. Okay, standard notation is regular numbers. Standard notation is how numbers are normally written. Now this, I was sort of asking in honest too, because I didn't know if you guys have really ever heard that phrasing before. I'm going to guess not, by the sounds of it, right? Okay. Standard notation is how you normally write numbers. If you want to write numbers differently, then they have other names. Oh gosh. Numbers. I said it out loud, but my brain's not back to teaching yet, I guess. Oh my gosh. You know what shouldn't be hard? Talking and writing at the same time. It shouldn't be hard, but it's hard for me. I feel like you guys should have heard place value, but maybe not. So the decimal point is the place value. Or maybe I should phrase that differently. I'll write an example, about the easiest. Oh, my smartboard's not back to working yet either. There we go. 432.67. The place value is me asking you what each number is referred to. So like the 3. What place in the number is that? That's going to be the tens, right? You've got ones, tens, hundreds. The place value is just the different numbers, what they're referred to. Scientific notation is a way to write very large or very small numbers shorter. Now they call it scientific notation because frequently very small numbers and very large numbers happen often in scientific areas. Like if you're counting up number of molecules, if you're measuring how large or how small something is, that frequently runs into in scientific areas. So This would be an example of scientific notation, is you have single digits with or without. Have you guys seen the W/O? Okay. And then times 10 to a power. So that would be an example of scientific notation. I'm assuming you guys have done that before. My guess is you've probably done it once a year for like the last 3 years or something. Have you even had to do it in science class yet? Okay, is that this year? Yeah, okay, good. It's part of the math standards to go over scientific notation, which seems odd since it's, you know, scientific, but we get to teach it. Okay. Okay, now the last couple. Come on. Base, if I have 5 to the third power, the 5 is the base. Whoa, what happened there? Exponent, if I write that same example, the 3 is the exponent. Most people refer to the exponent as the power. Do you guys want me to refresh you what 5 to the third means? Okay, so some people need that refresher. If you don't need the refreshing, you don't have to write it down. I'll just, so 5 to the third means I'm going to multiply 5 3 times. The 3 just tells you how many times. The base tells you which number you're multiplying. I feel like I don't need to write down product and quotient, but maybe we will. Oh well, let's go with you. Let's focus you. What's product and quotient? We actually just did it in the last packet, but hey, who knows? Even if you can remember one of them, don't tell them, really. Take a guess, if nothing. Don't worry, we only have 28 minutes left. Oh my gosh, are you just gonna stare at it and like think it's gonna come to you? Oh, I thought you would have just taken a guess, if nothing. Jordan.
Product is when the answer, when you multiply to get an answer. Quotient is when you divide to get an answer.
Perfect. We had these during the word problems. That's what I was trying to say by last packet. I know it's been a little while since you've thought about the last packet. So I wasn't trying to pretend like it was fresh in your brain. Is it possible you weren't even thinking about it during that packet? I see. I see. Well, let's change that up for this packet. Okay, so this is the main things we'll go over here that we're going to use this whole packet. You don't really need that stuff on the bottom. That's just, you know, if you want to know. Most of you know millions. That's probably all you really ever have to worry about, right? Like, it's very, very seldom that you're ever going to need to use billions or trillions. Unless you talk about how much in debt the U.S. is. Then you have to go about into the trillions. which is absolutely scary if you think about it, right? Like to us, thousands seems like a big amount. Well, 1,000 thousands is a million. 1,000 millions is billions. 1,000 billions is trillion. The US is way ahead. But we also make a lot of money, spend a lot of money, so it's kind of weird if you think about a whole country. Okay, oh, the joke. Honest story. I didn't write the joke, but I spent about 20 minutes this morning trying to find the answer for it. That was okay. I mean, there are worse uses of your time. I tried Googling it. Google had 5,000 results on how to do scientific notation. It did not have the answer to this joke. I had to go look it up from notes like 5 years ago to be able to find the answer. Does anybody think they know? Okay, so scientific notation means like numbers times 10 to a power. Standard notation is normal numbers. So if you go from scientific notation back to a normal number, you feel powerless. And I know it's a horrible dad joke and I love it. I used to have a dad joke of the day that we would put up on the front board. I kind of feel like I should bring that back. I used to have somebody in first hour that would just write the new one up every day because, you know, there's just a whole bunch of like Instagram, Twitter accounts that have a dad joke of the day. It was easy to find them. Are you guys yay or nay on dad jokes? I mean, it's okay to be nay, I just was curious. I think dumb jokes are the best. Sebastian, mid-Cheeto, mid-headphone, even though your phone's up here somehow. I understand that. Do you think we are supposed to be? Good, good, take them out. Do I actually have to check you guys for headphones and stuff every day? Come on. Okay, Sebastian, how do I write 1,000 as a standard number? That is 100% correct. What would that look like? You trailed off there.
1000.
Okay, 3 zeros. Good. Do you want to choose the next person? Moa? He's kind of already gone a couple times though. Okay, Moa, do you want to do 100?
Yeah.
Okay.
100.
Good, 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 good. I mean, these aren't supposed to be horrible, but. Okay, next person. Was it gone? Emma has not gone. Yeah, you did. You answered, didn't you? Yeah, too bad. Okay, how do I write 10 as a number? Yeah, this is a difficult question. Good. Can you pick? Yes. Alan, you have the hardest question of the day. Good call. We rate 1 as a 1. Alan, you get to choose the next person. Okay. Jackie, how do I? That isn't an actual column. I think this is just a place, a title. I think that is the title for those 3. How do I write a 10th as a decimal? That's what I was trying to say. 0.1, good. That is the 10th spot. Do you have a person you want to call in? How do I write 100th as a decimal? Ooh, close. Oh, actually, that does seem like it should make sense. But the way you're going to do that in decimals is it's actually 0, 1. So tenths hundredths, thousandths, yeah.
Oh.
Yeah. I don't know, the way you said it kind of threw me off, but that was 100% right. Okay, good. To be honest, the tenths, hundredths, and thousandths isn't used as often, so I figured that I need some refreshing on it. Okay, now power notation is just, how would I write 1,000 as a power of 10? So like the beginnings of scientific notation. Julian? How do I write 1,000 as 10 to a power? How many zeros are there? Good. That is exactly what you count to figure out what power to put on a 10. When you take 10 to a power, the number of zeros tells you like the power. 10 to the 50th power would have 50 zeros. Okay, do you want to call on the next person? Maddie? How do I write 100 as a power of 10? Good, good, good. See, you followed that instruction. Edlin, you have the toughest question. How do I write 10 as a power of 10? Good, 10 to the first. It has 1 0. It feels weird to write that, but hey. Now the next one is actually, there's a random
It's
pixel.
crooked too.
It's on your paper?
Yeah.
Oh, that's killing me. This next one is the one that most people feel like should be wrong, whatever. Does anybody know the answer? Good. It has no zeros. 10 to the power of 0 is because 1 is like a 10 with no zeros. Now, there's a reason why it's 0 power, but it doesn't matter. The counting of the zeros works for those. Now, when you get to numbers that are smaller than 1, counting up to zeros doesn't actually work, sort of. You're supposed to count up the decimal places. So the decimal point is normally to the right of the 1. This decimal point is 1 spot to the left. So we would say this is 10 to the negative 1. I mean, yeah, you can kind of figure out the pattern, right? Like the numbers were going down. 0.01, the decimal point is 2 spots to the left of where it normally would be. So this is 10 to the negative 2. When you're in the negatives, you can count the zeros, but it's 1 number off. Like this has 2 zeros, 1 0, no zeros. So however you want to like figure that out, go for it. Does anybody even remember how to do scientific notation from last year? Figured maybe I'll just ask that, or from this year even, I guess, if you guys did it. Like, does anybody know how to write 385 quadrillion as a scientific notation?
You would do what it said. You do 1 times 10 to the 15.
Close. So you're saying you're saying 15 because there's 15 zeros. I think, right? Yeah, it's not, you're not really wrong, but the problem is we're not allowed to write 385 times 10 to the 15th. Because on scientific notation, the first number has to be single digits. So we actually have to write 3.85. It has to be single digits. Yep. So we want the decimal to be right there, after the 3. And so we would count 17 spots. The heck if I'm going to write 17 little. 17 spots, it moves. So that's where we get times 10 to the 17th. I almost forgot to write that part. The other one works similar. except this is obviously an extremely small number. I'm just gonna tell you right now, there's no way my eyes are gonna be able to read how many spots that moves. So I'm gonna be counting on you guys. I'm going to write it as 3.85 again. How many spots is it from the decimal point till after the 3?
17.
Is it? Oh, yeah, I already know that there's no way I'm gonna be able to read that. It all jumbles together for my eyes. We got, sounds like 17 by multiple people. So I would put negative 17. Oh my God. All right. I'm gonna have to zoom in to do this. Can I tell you how embarrassing this is to get old?
Mr. McCloud?
Yeah.
Why do you do the times 10?
So that's how scientific notation is written. Okay, I'll count it. So we have 1, 2, 3.
Definitely 60. You kept a lot of zero.
If you guys are having trouble counting, you can do it like I am too, where you kind of group them. And that's only 2 spots. So 1, 2, 3, 4, 5, 15, 17 spots. So it's 16 zeros. I think that's where some of you are getting confused. There are 16 zeros, but I want to know how many spots I move to get it to be after the 3. Because I want to write it as 3.85. So I think that's maybe where some of you are getting confused. If you counted 16 zeros, that's correct. But it's 17 spots. On the test, I'm not going to give you one like this, because that would also require me to do it, and I know I can't read that. So I will test you guys on this stuff, but I will make them smaller so that your eyes won't jumble it together. Right. Oh, I should go even bigger. Oh, wow. Alan's got lofty goals. Okay, how do we answer this question? Who hasn't answered yet? Reagan, have you gone? Excellent. How do we know which number is bigger or smaller in scientific notation? What do you look at to figure out which one's bigger or smaller? Like, I can write 2 of them down if you want, if that helps. Okay. So let's do 4.37 times 10 to the 6th. And then we have 2.63 times 10 to the 8th. How do you know which one of those 2 is bigger?
I think we look at the power.
Perfect. You don't look at the single number, you look at the power. Whichever power is biggest. Now, if they're tied, then you would look at that number's over there. Isn't there stuff written below this in your packet? Oh, I thought I remembered something below that. Okay, so I'm just thinking of the next page in my head. Should I pause here? Does anybody need some help filling in anything that maybe they didn't get? You know, questions, whatever. We get done at 18 today. Oh. Yeah, you're right. I didn't even look at the clock when I asked the guys. I'm not planning on going straight to the end of the hour because I know you just got back. So I'm not gonna make your brain shut down immediately as soon as you get back to school. Awfully close though. Anybody? Anakin, have you gone yet? Oh, excellent. Now, obviously, all four of these have the answer written next to them, right? Do you think you can, words aren't working yet. Do you think you can figure out something by looking at those four? What at least do they have in common? They all have a 0 power. Now this one's a little bit different because it says the answer is -1. How come that one's different maybe? Yeah. So the -32 to the 0, that negative symbol is not on the 32. That negative symbol is on the whole thing. So do you remember like PEMDAS, right? Exponents come before multiply. So there's no parentheses written here, but that's how it acts. If that negative was supposed to be on the 32, it would have to be written like that, but it's not. So that negative is actually like out front. So anything to the 0 power equals 1. No matter what you have, if you take it to the 0 power, the answer is 1. It 100% feels wrong. It feels like the answer should be 0. But that is correct. I can show you why later, but I don't want to I don't want to kill you off yet. The class wire, oh, sorry, I wrote it on the wrong line. This is for both lines. Top one was supposed to be, did you figure out something from looking at those? Bottom one was supposed to be the actual rule. Okay, I'm going to stop there. We'll start with the negative powers tomorrow because they actually need a little bit of explaining.